Hello friends, welcome to Susan and John MathTube. Today we are going to continue our discussion in Fourier series. In the last two videos, we learned how to convert functions defined in an interval to sine and cosine using the Fourier series technique. And I think you watched the animation at the last part of the video, which might have given us a clear idea how functions can be written in terms of sine and cos. And writing in this manner gives us a very powerful technique so that we can write many functions of different types in just sine and cosines. Now today what we do is we will learn how to work out more problems on Fourier series, and that also in your exam point of view. In your examinations, they focus on three different types of problems. The first one, you will be given polynomial functions or algebraic functions. Let's say x square, x plus x square, etc. And another option is they might give you exponential functions. And a third option, they might give you functions which have trigonometric functions like sine and cos, or functions which come mixed up with sine and cos. Okay, now let's not waste time. Let's start with the first numerical. So I hope you're ready with a pen and a paper. So let's start. So look at this. Find the Fourier series representation. So please note the question. Find the Fourier series representation for the function x minus x square. And the interval is also given. Okay, in the second video, we learned that whenever we have an interval minus pi to pi or minus L to L or minus A to A, we might have some sort of advantage provided the given function is even or odd. But take a look at this function. This function is neither even nor odd. So I'm going to replace x with minus x so that you end up with minus x minus x the whole square, and that will be minus x square. So nothing happened. I didn't get the function, neither I got negative of the function. So that's it. So this function is neither even nor odd. So I'll repeat that part once more. If you have an even function or odd function with minus a to a, then you'll have some sort of advantage. But here what happened is we have a function which is neither even nor odd. So this minus pi to pi does not give us any advantage. Okay, so as always what we do is we write the length of the interval. So the length is 2L, and I told you to find the length you have to start from the last to the first. So we will end up with pi minus pi. So 2L will be equal to 2 pi, and that gives me L is equal to pi. Okay. Now on this side I'm going to write, let the required series be f of x equal to, so now you tell me what is the full range series? A0 by 2 plus sigma n equal to 1 to infinity. Yeah, tell me please. An cos n pi x by L plus bn sin n pi x by L. In the next line, we will substitute the values. What is f of x? Yeah, x minus x square is equal to a0 by 2 plus sigma n equal to 1 to infinity an. Now look at this. What's the value of L? Pi. And when we have L equal to pi, the angle will become nx. If you want, you can write it directly. Otherwise, you can write this step and substitute. Okay, now you can call it equation number 1. Okay. So, like I told you in the last day, our job is to find the constants. So here we go, A naught. So do you still remember the formula for A naught? 1 by L integral given limits. Given limits means minus pi to pi. F of x dx. But what's the value of L? Isn't it L equal to pi? Okay. So we will substitute. So A naught is equal to 1 by pi integral minus pi to pi f of x, and that will be x minus x square dx. Now we can integrate 1 by pi. If we integrate x to the power 1, we will get x to the power 1 plus 1 by 1 plus 1 minus x to the power 2 plus 1 by 2 plus 1 within the limits minus pi to pi. I hope you're all working out along with me, and whenever you watch educational videos, make sure you're always ready with pen and paper. And you're going to get 1 by pi. Okay, now let's substitute. So you're going to get pi square by 2 minus, that minus will come outside, or let's substitute it directly, pi cube by 3. Now I will put the lower limit. So squared will give me the same, and pi cube by 3. Now if you open the bracket, this quantities will get cancelled. So basically you end up with 1 by pi outside, and inside the bracket it will be minus 2 pi cube by 3. So I'm going to write the final value. A naught is equal to minus 2 by 3 pi square. So put it in a box so that we can use that for further reference. Okay, now the next one, an. So the formula is 1 by L, but L is pi, and integral of given limits. The function, I know the function x minus x square and cos n pi x by L. But since L equal to pi, it will get cancelled, and we are going to get cos nx dx. Okay, now one very important thing. I told you in your examinations they tend to ask 3 different types of questions. Sometimes they ask polynomial functions like this, algebraic functions, and sometimes they end up asking exponential functions, and sometimes trigonometric functions or functions which are related to trigonometry. Okay, so whenever you have polynomial function, you must apply Bernoulli's rule so that you are able to integrate very fast while you find an and bn. And whenever you get exponential function, you apply the direct formula related to integral exponential and sine, or exponential and cos. Okay, now let's continue. So an is equal to 1 by pi. Okay, let's integrate really fast. So first function, what's the first function? And then in another bracket I'll write sine nx by n within the limits. Tell me what are the limits? Minus pi to pi. And then minus inside another bracket. Okay, so tell me what is the derivative of x minus x square? 1 minus 2x. And now tell me what will happen if you integrate this. Okay, we are going to get minus cos nx by n square. And that will be within the limits minus pi to pi. One very important thing, I have seen students trying to combine this minus and minus while applying Bernoulli's rule. Right now I am applying Bernoulli's rule. Don't do that. The next term might be wrong in terms of plus or minus. So 1 minus 2x, the derivative is minus 2, and cos, the integral is sine. So minus sine cubed up to this minus pi to pi. Okay, now the next step is the what you call cleaning up. And by cleaning up, what I mean is you'll keep the unnecessary quantities outside. And you can even combine this negative and negative and make it positive. I'll remind you once more, don't combine these things when you are applying Bernoulli's rule. Your answer might go wrong. Okay, now let's go for the next step really fast. An is equal to 1 by pi. So this 1 by n is going to come outside. Sine nx within the limits minus pi to pi. And here it will become plus 1 by n square. And tell me what is inside the bracket? 1 minus 2x and cos nx within the limits minus pi to pi. And the last one, it's going to be plus 2 by n cube sine nx within the limits minus pi to pi. Okay, so let's erase the steps above. Okay, and you can try by yourself substituting the limits, etc. So try it. By the time I erase this, you can start. Yeah. So an is equal to 1 by pi. Okay, now tell me what might happen if I input the upper limit. Only get sine n pi, and we have learned sine n pi equal to 0. And what is sine minus theta? Because when we substitute the lower limit, it will become something like minus nx. So remember, this negative will come outside. So when I substitute the lower limit, it will vanish. So I'm not worried about the first term. It's going to be 0. Now 1 by n square. Now tell me what will happen when you substitute the upper limit instead of x. I can see x here and here. So 1 minus 2 pi cos n pi is minus 1 the whole power n minus 1 plus 2 pi into minus 1 the whole power n. And when you substitute this here, sin n pi, cos sin n pi and sin minus n pi, both are zeros. So 1 by pi and 1 by n square, and minus 1 the whole power n will float outside, and the remaining part is 1 minus 2 pi minus 1 minus 2 pi. So I'm going to cancel these two, and you're going to end up with 4 by n square minus 1 the whole power n plus 1. I skipped one step, but I'm sure you'll be able to understand that. So let's note that an, because at the last we want all these values. Okay, moving ahead. So tell me what to find next. Yeah, of course, bn. So bn will be 1 by L, but L is pi, integral given limits, and the limits are minus pi to pi, and f of x is x minus x square, and sine n pi x by L, but L is pi, so we have an advantage, we write nx. Okay, now look at this. It's in the form of a polynomial and trigonometry. So the best method is Bernoulli's method. So let's start just like before, 1 by pi, and I'll put a big bracket. Okay, now tell me, let's do it very fast. If you want, you can try it yourself. Okay, so it's minus cos nx by n. One very important thing in Fourier series is you should learn how to solve these problems really fast, because you have plenty to write, and even if you make one simple mistake or anything, like let's say plus or minus goes wrong, or you forgot to write one n, anything, let it be any simple mistake, you're going to pay a lot, because you will waste time and you won't get mark. So even though Fourier series is easy, it will be much better if you practice a lot. That's it. So I hope you understood this. The function, the derivative, and again derivative. Integral of sine is minus cos, and then sine, and again minus cos. Okay, so what's the next step? Yeah, of course, cleaning up. So let's start cleaning, and I'll recommend strongly that you don't skip this step. I told you the same thing in the last two videos. This step is extra important, cleaning up process. Many students try to substitute the limits here. Okay, they might get answer, but it's better to do this, because it kind of guarantees we will get the answer for sure. Minus will be plus, and 1 minus 2x sine nx within the limits minus pi to pi. You can even message me things directly from our website www.sjmathtube.com. Now we have the direct chat feature there, so you can just go to my website and scroll down. You'll find the messenger link there. You just if you have any doubts in this topic, you can ask questions, or if you want to give me some suggestions, you can do it. Okay, that's it. So I'll erase the above steps, and I think I should leave the remaining steps for you. So you can substitute. This will give us some value. This is going to vanish, and this is going to vanish. So bn will be equal to, I'll just try the last step. Just check it out. The whole divided by n, and there's a 2 over here. So that's it. So we found a0, an, and bn. So we will find what is equation number 1. So I hope you still remember equation number 1. So let's substitute directly here. X minus x square is equal to a0. Yeah. So half of this will be minus pi square by 3 plus sigma n equal to 1 to infinity an, and an is here. So I'll write 4 by n square minus 1 the whole power n plus 1 cos nx plus sigma, I'll use one more summation, n equal to 1 to infinity. I still remember the value of bn, 2 by n minus 1 the whole power n plus 1 sin mx. So that's it. This is our Fourier series. Now we can put n equal to 1, 2, 3 and expand. So let's check out one more problem that is extra important. So the question is, find the Fourier series. You can note that question. Find the Fourier series of the function f of x is equal to x into sin x. I told you, trigonometry, algebraic functions and exponential function. Of course, this is the second type. And the limits are from minus pi to pi. Okay, whenever you get the limits from minus pi to pi, you should remember to check whether the given function is even or odd. Because if the limit is in the form minus a to a, and if the function is odd, then you don't have to find a0 and an. And if the function is even, you don't have to find bn. At least we'll have some advantage. Okay, so that's exactly what I'm going to do. So I'm going to replace x with minus x. So I'm going to replace x with minus x. So that minus x and sine minus theta. What is sine minus theta? Minus sine theta. So together, I'm going to skip that. It is x into sine x. Okay, so like I told you in the last video, this function has the capacity to make that negative disappear. So this is an even function. Now what's the advantage of even function? You can forget about bn because the limit is in the form minus pi to pi. Okay, so let's start. So as always, let the Fourier series be f of x equal to a0 by 2 plus sigma n equal to 1 to infinity. Wait a minute, I forgot to calculate the most important thing, the length. So the length is 2l, and that will be, we did the same thing in the last question, that is 2 pi. So L is equal to pi. Okay, so the formula will be an cos n pi x by L. Okay, now the good news. The good news is, since bn will be 0, there will be no sine terms in the answer. That means our answer will be completely in terms of cos. Now the left side, that will be x into sine x is equal to a0 by 2 plus sigma n equal to 1 to infinity an into cos nx, and you can call it equation number 1. Okay, now we have to find a0. So look at this, we have an even function and the limits are from minus pi to pi. So when we calculate a0, remember we don't use 1 by L but 2 by L. Of course I know L is pi, and half the job, it's not from minus pi to pi but 0 to pi. If you don't understand these things, then I'm pretty sure you left video number 2. So if you're confused with this even function, odd function, etc., pause the video right now and check out video number 2. And f of x is x into sin x dx. So that will be 2 by pi. I'll put a big bracket. Okay, now apply Bernoulli's rule. And that will give us first function minus cos x within 0 to pi minus derivative and minus sin x within the limits 0 to pi. Okay, now look at this, the cleaning up. Let's clean it up. I'll strongly recommend don't forget this step. Now let's substitute the limits. 2 by pi, and you're supposed to put the values here. I'll change that color. So pi and cos pi. Cos pi is minus 1, so we get minus of pi into minus 1. When you put this lower limit, you're going to get 0, so minus 0, because sin pi is 0, and yeah, that's it. So I'm going to declare the final answer. A0 is equal to, yes, 2. Okay, so let's move ahead. Now we have to find an. So don't forget, it's an even function and the range is minus pi to pi. So together we have a huge advantage. Advantage number 1, we don't have to find bn. And advantage number 2, instead of writing the limits from minus pi to pi, we will simply write 0 to pi. But it will be 2 by L, which is pi. And f of x is x into sin x. And cos n pi x by L, which simplifies to cos nx. While doing problems related to trigonometric functions, make sure your trigonometric formulae are in very good condition. So we are going to manipulate our integral a little bit. So I'm going to write this part in a bracket, and I'll write cos first because the angle looks a little bit bigger than the other one, dx. Okay, I hope you're good with formulae, and you might have heard the formula cos A sin B. These formulae are really simple. These are just adding sin A plus B and sin A minus B, or subtracting sin A plus B and sin A minus B, or doing the same stuff with cos. And here it is sin A plus B minus sin A minus B. This will be sin A cos B plus cos A sin B minus sin A cos B. So they will get cancelled and other two will get added up. But you'll get 2 times, so you put 1 by 2. Now let's come back to our question. So this is like 2 by pi integral 0 to pi x into, okay, so 1 by 2 brackets. I'm going to apply that formula cos A sin B. So look at this. Instead of A we have nx, and instead of B we have x. So half into, in brackets I'm going to write sin nx plus x. Now tell me, what is nx plus x? This x will come common, so that is n plus 1 into x. So I'm going to write n plus 1 into x minus sine, that will be nx minus x, or n minus 1 into x, and of course our dx. Okay, now these characters will get cancelled. So anyway, I'll write an is equal to, I'll throw the constants outside, 1 by pi, and then I'll write this integral once more a bit neatly, 0 to pi x, and in bracket sine n plus 1 into x minus sine n minus 1 into x dx. So we can get rid of this completely. Okay, can you see a product here? Of course, our u and the quantity inside the bracket, a v. Okay, so this can be simplified to 1 by pi, and let's put a big bracket. Now we are going to apply integration by parts or Bernoulli's rule, but I prefer Bernoulli's rule because everything will be over in one step. So the first function and then the integral of this part, and that will be minus cos n plus 1 into x by n plus 1, and minus minus will be plus, and that gives me cos n minus 1 into x the whole divided by n minus 1, and this is within the limits 0 to pi, minus in another bracket 1 into the integral of this quantity, that will be minus sine n plus 1 x the whole divided by n plus 1 the whole square, again plus sine n minus 1 x by n minus 1 the whole square, and that also within the limits 0 to pi. If you want, you can take common, and that will give us minus, it's not compulsory, but if you want, if you feel like it, you can do that. So if minus is taken outside, you will end up with cos n plus 1 x by n plus 1 minus cos n minus 1 x by n minus 1 within the limits 0 to pi. And again I'll take minus outside, so I'm going to that positive, and we will get sine n plus 1 x by n plus 1 the whole square minus sine n minus 1 x by n minus 1 the whole square within the limits 0 to pi. To be honest, this step is not compulsory. Okay, now I'll erase and I'll substitute the limits, and that's it. Here we get 1 by pi, and then you can put the upper limit. The upper limit is pi. So when I put pi here, of course I'll get pi, and inside the bracket I'll get minus 1 the whole power n plus 1. Look at this, cos n pi will be minus 1 the whole power n. So cos n plus 1 pi will be minus 1 the whole power n plus 1. the whole divided by n plus 1 minus minus 1 the whole power n minus 1 by n minus 1. And when you put the lower limit, you're going to get 0 into something. So you don't have to worry about the lower limit, that will be 0. And now again good news. The good news is when you put sine n plus 1 into pi or n minus 1 into pi, they will vanish and sine 0 is 0. So the last term will be gone. Now that said, we have to manipulate these quantities a little bit. So minus 1 by pi, and then we have pi, and I'm going to write this. I hope you remember a power m plus n can be written as a to the power m and a to the power n. So I'm going to write this as minus 1 the whole power n into minus 1 by n plus 1, and then minus 1 the whole power n into minus 1 the whole power minus 1 the whole divided by n minus 1. So these quantities will get cancelled. Okay, now let's take this negative inside. So it will be minus 1 to the power n. Minus into minus will be plus. And here minus minus. Look at this. Minus 1 the whole power minus 1 is 1 by minus 1. And that will be minus 1. So minus 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 will be minus the whole power n by n minus 1. And that means we have something common, and 1 by n plus 1 minus 1 by n minus 1, and that's equal to minus 1 the whole power n. We can take LCM. That gives me n square minus 1. I hope you're good in algebra. Yeah, so these things will get cancelled. Write the final answer. An is equal to minus 2. What will we get? 2 into minus 1 the whole power n plus 1 the whole divided by n square minus 1. Okay, now this is really critical. So look at this. Till now, whenever we get an, we will be very happy with the answer. But this time I'm not happy with the answer. So remember, this question is extra important for your exam. So I hope you remember equation number 1. So we are going to plug in n equal to 1, 2, 3, 4, etc. And when we plug in n equal to 1, we get a1. Now by looking at this answer, you can see that when we plug in n equal to 1, the denominator will disappear. The denominator will become 0 and we get infinity. So always remember, in such problems, you have to recalculate a1. So look at this. An is given by 1 by L integral f of x cos n pi x by L. So if you want a1, all you have to do is you have to replace this n with 1. So a1 will be, okay, 2 by pi, because our problem was even and the limits were from minus pi to pi, and f of x is x into sine x, and the whole thing will be reduced to, because pi and pi will get cancelled, n will be 1, so you're going to get cos x dx. And I hope you remember a formula from your younger classes. If you don't remember, then I have to make you remember. So look at this. I'm going to take this 2 inside, I'll write 2 sin x cos x. By the way, I didn't forget this x. Tell me, what is 2 sin x cos x? Yeah, that will be 1 by pi integral 0 to pi x into sine 2x dx. Now it's time we applied Bernoulli or integration by parts. I'll always recommend Bernoulli's rule because it saves a lot of time. Now tell me, what is integral of sine 2x? Yeah, minus cos 2x the whole divided by 2 within the limits 0 to pi minus the derivative of x is 1 and the integral is minus sine 2x by 2 square within the limits 0 to pi. So I'll erase all these things. Now let's substitute the limits. 1 by pi. Okay, cleaning up. Minus 1 by 2. You have x into cos 2x within the limits 0 to pi. 1 by 4 sine 2x. So you can put this limit, this is going to be 0. So when you put this, you're going to get a1 is equal to minus 1 by 2. So this is very important. We are going to plug in the values 1, 2, 3, 4, etc. So always be aware, when we plug in these values, this quantity should not become infinity. In case it becomes infinity, all you have to do is, I'll give you an example. Suppose you got an is equal to something by n minus 3. That means when you plug in n equal to 3, you're going to get infinity. That means you have to find a3 just as I found a1 here. Okay, so let's go back and write it in equation 1. I just want one more value. Where is that? Yeah, a0 equal to 2. Okay, so a0 equal to 2. So by equation 1, x into sine x is equal to a0 by 2. So 2 by 2 is 1 plus, look at this, we have sigma n equal to 1 to infinity an cos nx. And I'm going to write this as 1 plus, I'll substitute 1 here. So I get a1 cos x plus I'll write sigma n equal to 2 to infinity an cos nx. Now all you have to do is you have to substitute the values. 1 by 2 is from here, cos x, and then an is over here, plus sigma n equal to 2 to infinity 2 by n square minus 1 minus 1 the whole power n plus 1 cos nx. So that's it, that's the answer. Now let's focus on one more type which they ask for the exam, and from the next video onwards we'll be discussing about half range series. And if you want me to work out some particular problem for you, I'll repeat, you can contact me in my email, it is in my website, or you can message me in Facebook, or you can follow me in Instagram, or do the best thing, take my website www.sjmathtube.com and you scroll down and you can use Messenger to contact me. Anyway, for the time being, the last question. Obtain the Fourier series for the function f of x is equal to e to the power 3x and the interval is 0 less than x less than 2 pi. Okay, so just like I promised when I started the video, I told you in the examination they tend to ask three different types of question. One is algebraic functions, or let's say our polynomials. So while integrating, Bernoulli's rule will always help you. And the second type, trigonometry, that's the one which we saw. So you will have to apply the formulae like sin A cos B, cos A sin B, cos A cos B, and then you'll be able to proceed. And the last one, exponential function. In exponential function, what we do is we use the integrals, integral e to the power ax cos bx dx, or we use the formula e to the power ax sin bx dx directly. So the formula goes like this: e power ax the whole divided by a square plus b square, and in bracket. The trick is, you remember this diagonally, so I write a cos bx, and I keep in mind I'm doing integration, so integral of cos is plus. So that's a trick I use to remember this formula. Yeah, and of course constant. And here what we do is we get e power ax by a square plus b square, and I told you, think diagonally, a sin bx minus b cos bx. I told you the trick. Remember, we are doing integration, so integral sign will be negative. You can use any memory aid you like, but the final answer must be correct. And of course, some of you may need this. Integral e power ax dx is e to the power ax the whole divided by a plus c. So let's move ahead. So as before, a naught. So what was the length of the interval? I'm not going to write those things. Yeah, so 2l is equal to 2 pi. So l will be equal to pi, and let the series be dot 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 etc. So let's proceed. So we get a naught is equal to 1 by l, that is 1 by pi, and the limit 0 to 2 pi, and function value is e to the power 3x dx. And I'm sure you know how to integrate this. E to the power 3x the whole divided by 3, 0 to 2 pi. Now let's throw this quantity outside. Now put upper limit. So I'm going to get e to the power 6 pi minus, when I put lower limit, I'll get e to the power 0. So I'm going to write our a naught here. A naught is equal to e to the power 6 pi minus e power 0 is 1, the whole divided by 3 pi. Let's put it in a box as always. Now the next thing, an. So an will be 1 by pi integral, of course, the given limit, and the function e to the power 3x and cos n pi x by l, which reduces to cos nx. Okay, now look at this. I already gave you the formula in the beginning. You can check it out. So e to the power 3x by 3 square plus n square. I had to put a bracket here. And think diagonally, 3 cos nx. And now time to think about integration. Integral of cos is positive, so that gives me the confidence. I'll write plus sin nx within 0 to 2 pi. Now let's write it a little bit neatly. 1 by 3 square is 9. So pi into 9 plus n square, and then it's e to the power 3x 3 cos nx plus n sin nx within the limits 0 to 2 pi. So you get 1 by pi 9 plus n square, and then when we put the upper limit we get e to the power 6 pi, and cos 2n pi of course is 1, so we get 3 plus 0 because sin 2n pi will be 0, minus e to the power 0, and then again 3 plus 0. So I'll take common. I'm going to do that in my mind because 3 is going to come common and e power 0 is 1. So I'll write the final answer as 3 by pi into 9 plus n square, and here we'll get e power 6 pi minus 1. Okay, so I'm going to write the answer here, but make sure you get this answer. I want you to try and find bn by yourself. So I'm going to stop this video right now. So I told you in your examination they normally ask these type of questions, but these 3 questions are not enough to get you good marks. If you really want good marks, then make sure you practice a lot of questions in Fourier series. So if you like the video, share, subscribe with your friends, and of course go and check my website. I have made a few improvements. You can go through the website. Now you can get a downloadable PDF, like you can check, you can scroll a little bit below this video if you're watching it in the website, and you'll see a download button, and you'll get the PDF version where I have done all the problems. Anyway, share the good news with your friends, and I'll be back with another video in which we'll be discussing about half range series. Okay, so till then, bye.